always
No,
the snaps that
okay,
like
let
you
me
don't
say.
like
My mom
purposefully get
bought
them,
those,
but then it's like when
she
somebody
bought
else
the
has them,
regular
you're like,
ones for so many
sounds
like,
really
months
good.
that I was under
My mom has a
them.
Thai
So
one.
then I was like,
All right.
Except she does mine for her class.
now those were so long ago.
That's like I'm a student.
So-
therefore I need gold
She never talked to me.
When we talk about polar derivatives, I'm going to show you like what the book has. But really, I would prefer you to just remember that dy dx is dy d theta over dx d theta. Okay? Which makes sense, right? dy d theta over dx d theta. Okay? In polar form, x is what? Okay. X is r Lord. X is r cosine theta. Now we're on a roll here. Okay. R could be a function in terms of theta. And so I'm going to go ahead and write this. Okay. Same thing for y. In polar form, y equals r sine of theta. Okay. But r could be a function of theta. And so we would need to account for that. Okay. Now, when we talk about the derivative dy dx, yeah. Thank you. When we talk about dy dx, we would have to take the derivative of y over the derivative of x. Okay, I don't want you to remember that. How did I get those? I used the product rule for y and the product rule for x, but I don't want you to try to recall what I have written in red right here. Okay, I want you to remember that dy dx is the derivative of y divided by the derivative of x with respect to theta. Okay, now as you can see, it's not pretty. Okay, because we have a product a majority of the time for our x and y. But we know the product rule. We know what x and y, what they represent. So just being able to do this from the product rule is really all I want you to do. Don't memorize the red. Just know that it'll probably look like this and it's not going to be beautiful. Okay. All right. So we're going to write the equation to the tangent line of the polar curve r equals 5 sine theta at theta equals pi over 3. Okay. So, when we talk about a tangent line, we need the slope. And when we think about slope, we think about dy dx. Okay? R prime is really not going to help us with slope. Okay? We need dy dx. So what we are going to have to do, I know you're excited, is we are going to have to write that x equals r cosine theta and y equals r times sine theta. So are you okay if I just write sine squared instead? Okay. So we're going to write out we're going to actually find dy dx. Band, you have until 10:10, is that correct? Okay. So the derivative of y, we would have 10 sine theta cosine theta. Do you agree with that derivative? Okay, power rule, chain rule. Over the derivative of x. Okay. So what's the derivative of 5 sine theta? So we have the derivative of 5 sine theta times cosine theta plus 5 sine theta times the derivative of cosine theta. Are you okay if I wrote it like that? Okay. Now, you don't have to go through any simplifying. Just leave it like this. I know it looks messy, but that's fine. Okay? If I ask for the derivative, you're welcome to stop here. But what I'm asking you for is the tangent line equation. So we are going to have to evaluate this at theta equals pi over 3. Okay? I'm teaching the unit circle in pre-calc. Well, I did yesterday, and we kind of worked with it today. Okay? And they're wondering why I teach them the unit circle. I said when you get to calculus, you don't want to have to draw triangles. You want to be able to remember, so you can do the calculus. Would you find that to be accurate?
Oh, yeah.
Okay.
Did you have Quentin in your class?
I do.
Yeah, I was helping him through that last night.
Like I don't know if you remember your pre-calc days, but they, you're learning the unit circle, like, but it makes life so nice in situations like these, right? 10 sine of pi over 3 cosine of pi over 3.
I didn't know what you were.
What? Let me know when you get this simplified here. What do we get?
Oh, yeah, because I just kept it around.
Yeah. Well, that's a nice number.
It's medium nice.
Medium nice.
You know, might play a few pranks on you, but mostly nice.
Okay, well now we're going to write the tangent line equation. What else do we need?
X and Y.
We need the xy coordinate, right?
There's so much work involved.
No. So y minus, when we plug pi over 3 in for y,
What?
15/4.
I don't know what you just asked, but
Theta is pi over 3. I want to know what y is. Check her work. Could you agree with 15/4? Full slope times x minus, and we plug pi over 3 in for theta in the x equation.
We need a code word for our viewers at home.
Code word.
pep rally.
Yeah. Code word. Sorry you missed the pep rally, but pep rallies aren't that fun. So glad you missed the pep
To
rally.
be honest,
That's the code word.
You are like the least peppy class.
Pep rallies are
What?
awful because there's so many people in that like compact area.
oh no, I just
I don't
can't,
care
I
about
can't tolerate
sports. I don't care what the basketball people are doing.
She's like,
But it's not just about sports.
I-
Swirlies are twirling today.
Yeah, I don't really care about them either.
stop.
Oh,
Yeah.
Hey, as long as you dislike everyone equally, I mean that's
Yeah,
fair.
it is.
No, I don't know from school.
One time the show choir performed, that was really exciting.
One time
Right.
I performed for
That
WGI,
was nice.
and
I would-
the
I've
funniest
never
thing
had
only
it.
happened once. I never had one again.
Yeah.
I enjoy seeing the students like do the games in the middle.
Yeah, that's
I
okay.
enjoy that part of it. I do. All right, so let's talk about horizontal and vertical tangents. I'm going to go back to our first slide here. If I ask you to find where we have horizontal tangents.
Where like the numerator is 0.
Okay, so if we have a derivative, we're talking about numerator, which is dy theta, okay? Vertical tangents is where our denominator of the derivative is 0, so in this case it would be dx d theta. Okay, so go ahead and write down r equals 1 minus cosine theta. What is it? It's a limosone. What kind of limosone? It is a cardioid. A and B are the same. It is a cardioid that opens to the left. Very good.
We did it.
All right. So visualize the cardioid for a moment. Can you visualize where we might find horizontal and vertical tangents?
Oh yeah.
Sounded like the Kool-Aid man when you did that. Oh yeah.
That's always my goal.
Okay. Okay, so let's work on horizontal. We decided that horizontal we would need to find what? dx d theta or dy d theta? Okay. So dy d theta. Okay. Let's come back up here. Our equation is r equals 1 minus cosine theta. So we need to take into account that y is r sine theta. Do you want to leave it like that or multiply it through? Multiply it through? Same amount of work, probably. Okay? All right, so if we take the derivative of sine theta, we get cosine theta minus, we have a product. I'm going to go ahead and just leave the subtraction out here, so let's just work with cosine times sine. Okay? So the derivative of cosine is negative sine times sine plus cosine times the derivative of sine, which is so what we have is 0 equals cosine of theta plus sine squared theta minus cosine squared theta if we go ahead and take that subtraction through. Now, you may see why I gave you the assignment that I did on Tuesday. We need to solve for our angles. All right. What are we going to do?
Turn sine squared into 1 minus cosine squared.
Why are you choosing sine squared?
Because the other terms are already cosine, so you can make it everything cosine.
Okay, so this is cosine squared, this is cosine to the first. If we change this to 1 minus cosine squared, we're going to have a quadratic all in terms of cosine. Okay. Okay, I'm going to be crazy here for a moment. I like trinomials where the leading coefficient is positive. Okay? So what I'm going to do is I'm going to combine like terms, but then I'm also going to multiply by -1 at the same time. So that we have 2 cosine squared theta minus cosine theta minus 1.
I feel like
Gabe, do you have a question on the 1
just
minus
the
cosine squared?
substitution.
Okay, so we know that,
Yes, I know what you're writing. How,
Okay.
How did we get the 1 though? Because I have a minus and a positive sine squared, cosine squared.
how did we get this one?
Yes.
Sine squared, I rewrote as 1 minus cosine squared. Sometimes you just have to visualize it. It's fine. Now we have a trinomial that we need to factor.
It's just a cosine.
This is just horizontal, yes. Well, we know to get 2 cosine squared, we need 2 cosine times 1 cosine. We need to multiply to -1.
Plus 1 and minus 1.
Okay, so where do they go?
Plus 1 and minus 1.
Oh, you were actually answering both. Okay, sorry. Because this would give us +1, this would give us -2. Together they would make that -1. Okay? So, it always makes me nervous when I hear those noises. This right here, we're going to set equal to 0, which essentially means the cosine of theta equals -1/2. Are you okay with me jumping to there?
Yeah.
Okay. So that happens. Once again, unit circle.
Pi over 3 is pi over 3.
And over here, we want to know where the cosine of theta equals 1. And that was only for. Okay. Now, we really do need the coordinates. Well, we're going to find the coordinates, yes. This is where they occur. Let's actually find the coordinates. But let's wait and find our vertical first. Okay? Because something strange may happen.
Oh, I know what's gonna happen.
What?
It's gonna be pointy. Not smooth. Because it's pointy.
Because it is pointy.
It's
Okay.
Pointy, as Mr. March said.
Really thought I could get a soap bubble. Determined to see it through.
All right, so dx d theta is 0. That's how we're going to identify vertical tangents because that would be the denominator of dy dx. Okay? Now, our equation is way up there. You probably have it written down on your paper to see. But let's go ahead and make a note to ourselves that x equals r cosine theta. And I'm guessing you want to simplify that before we take the derivative because that's what we did last time.
Maybe that should be the code word. New code word. Scratch that whole thing about pep rallies.
Actually, there's a new code word every 5 minutes, and then they have to remember each code word.
Oh,
That
to
way
make
we
sure
know.
that they watch
Yeah.
the whole video and they aren't just like watching.
I don't remember that many codes. I have the memory of a gold.
Okay. dx d theta. Derivative of cosine minus the derivative of cosine squared. Okay, we need to set this equal to 0. What can we do with this?
Take out a side theta.
We have a greatest common factor. Please always, always, always look for a greatest common factor before you do anything else. Because it makes your life so much easier. Okay? So, we need to look at where the sine of theta equals 0. Which occurs at 0 and pi. Would you agree? Okay. And we need to look at when we set this equal to 0, that means the cosine equals a positive 1/2. Right? Okay. And that happens at the other pi over 3's. Okay. All right. So look at our list of horizontal and vertical tangents. Do you notice anything?
Zeros on both of them.
Okay, zeros on both. That's not okay. That is a point where our curve is not smooth. Remember back, flash back here with me to parametric, right? If dx dt and dy dt were both 0, then we had a non-smooth point. The same thing happens here because we've essentially written parametric equations, if you think about it, where we have x and y in terms of theta, a third variable. Okay? So we are not smooth at 0. We knew that this was a cardioid, so we can visualize where that is, right? Cardioids come to that point. We can't have a tangent there. Okay? So now I have 2 points of horizontal tangency, 3 points of vertical tangency. Does that make sense with a cardioid that opens to the left?
Yeah.
Right? 1, 2, 3. Vertical, 2, horizontal. That's a terrible graph, but that's fine. So then if I would want the coordinates, we would have to go back and plug 2 pi over 3 and 4 pi over 3 in to figure out what the r value was. And then down here we would have the same for pi over 3, and 5 pi over 3.
Teachers, at this time, please release the band and color guard students to get ready for the pep rally. Again, please release the band and the color guard students at this time. Thank you.
There's one more thing that we will talk about, so make sure you check the end of the video with a new code word.
New code. Oh yeah.
Okay, has anyone started plugging those in to the r equals 1 minus cosine theta? Play loud. And on beat. 1 minus cosine of 2 theta. I say?
I don't
1
remember.
minus cosine of 2 pi over 3 is what my words wanted to be.
Uh,
And that's the same for 4 pi over 3 as well. 1 minus cosine of pi.
Oh. That's right.
1 minus cosine of pi over 3. Same for 5 pi over 3.
Oh,
Okay.
big confusion.
Alright.
Okay.
Rose curve. If f of alpha equals 0, but f prime of alpha doesn't equal 0, then the line theta equals alpha is tangent at the pole to the graph. How many tangents to the graph that go through the pole do you think this will have?
Can you reword that sentence? I'm not sure if you were asking.
1.
How many tangents?
How many
The
tangent
graph.
lines of this rose go through the pole? Okay, our rose does equal 0 3 times. Let's find those 3 times. Where's cosine equal to 0? So you know from your experience with rose curves that since there are 3 petals and it's a cosine curve, we only have 3 zeros. So I'm going to list the first 3 times the cosine is 0. When we divide by 3, we would have pi over 6, pi over 2, and 5 pi over 6. Now the key here is, will the derivative be 0? We don't want the derivative to be 0. Okay. What do you think? Is the derivative going to be 0?
Doubt
You doubt it? Our derivative would be negative 6 sine of 3 theta cosine theta minus 2 cosine 3 theta sine theta. Oh no, that's the denominator. I'm so sorry. I got excited and I did x first. So I'm just going to move it to the denominator. I think I have a smart board, I can just literally move it. Do you agree with my dx theta? We can't combine the cosines there because one has an angle of 3 theta, one has an angle of theta. Okay. And then dy d theta, we would have negative 6 sine of 3 theta sine theta plus 2 cosine of 3 theta cosine theta. That would be our product rule there. So if we plug in pi over 6, pi over 2, 5 pi over 6, would any of them ever equal 0? So how about pod 5? Check pi over 6. Pod 4, check pi over 2. And pod 7, check 5 pi over 6. Make sure they don't equal 0. Oh, my email's blowing up over here. Anyone have confirmation for me? Victoria?
This one are these tangent lines always gonna equal like radical 3 over 3 or 1? Like the tangents on the circle?
Yeah.
No, not necessarily, no. These might have just been special. Did pi over 6 work? Did pi over 2 work? Well, that kind of makes sense, right? Look at that. Okay, we have about 7 minutes left. You want to get organized for your homework for the weekend? If any of you want to leave your stuff in here for the pep rally, I have no problem with that. You'll just have to come get it before you go to 4th hour. But that is a possibility. I would leave it like up here so that if my 4th hour starts to get here before you, you're not in their way.